Hello everyone, in this video we're going to pick up where we left off in section 12.3 and we'll look at example 3 here. The path of an object moving along the space curve C is given by RT equals Ti plus T cubed J plus 3TK for T greater than or equal to 0, and we want to find the velocity and acceleration vectors when T equals to 1. So just to get an idea of what's going on here, let's describe the curve that's made by R of t, right? So using the parametric equations, x of t equals to t, and y of t equals to, or actually we typically don't use t there, do we? So we'll just say x equals to t and y equals to t cubed. We know what's going on. We can determine that the path of the object lies on the cylinder given by y equals x cubed, right? So remember the idea here when we're talking about these 3D shapes, y equals x cubed is called the generating curve, I think was the name of it. And then remember that as the t value goes bigger here, the z value is going to change, what gives it the height. Right, so this is in general just a cylinder, and that is its generating curve. Moreover, since t, let's say since z, the other parametric curve, is 3t, and at t equals to 0, the position of the object is, well, if I plugged in t equals to 0, and all these places I would get 0, 0, 0, right, because they all have t in them. So what does that mean? That means since z is equal to 3t and it starts at 0, 0, 0, the object starts at the point 0, 0, 0 and moves upward as t increases, right? Because it says t is greater than or equal to 0, and we're plugging it into here, so that gives us a positive t value because we're just multiplying by a 3. So because of that, the object starts at 0, 0 and moves up word as t increases. So I'm not very good at drawing that, so let's look at the graph here. That's what we've got going on. So this curve, it starts at 0, 0, 0, right? It starts here, and then it moves up to that spot there, right? And so now the question is to find the velocity and acceleration vectors when t equals to 0. So we need to find the velocity vector. So that again is the derivative of the position. So if I took the derivative, I'd get I plus 3t squared j plus 3k, right? And then my acceleration vector, which is the derivative of my velocity vector, is going to be 0i plus 6tj plus 0k, right? So at t equals to 1, my velocity vector looks like I plus 3j plus 3k, and my acceleration just looks like 6t, well, we plugged in 1, so it just looks like 6j. And so what we can do, that's what they are. right? And that's what the question asks for. If we're going to draw it on our curve, we know that this is where we start at, so maybe we'll erase this and we'll say we start right here, right at 0, 0, 0. We move up the curve to get here. This is our point. This is at t equals to 1. And then there we have drawn the velocity and the acceleration vector, right? This is the velocity vector that's coming out there. And this velocity vector goes out into the 3 dimensions, right? This acceleration vector here, a of 1, if you notice, just moves in the one direction 6j. In other words, it's parallel with the y-axis right here, right? These lines are parallel because it's just 6j, right? There's no x or z component in the acceleration vector. Okay, so now last question. An object starts from rest at the point 1, 2, 0 and moves with an acceleration given by a of t equals to j plus 2k, where a of t is measured in feet per second. And we want to find the location of the object after t equals 2 seconds. So when this says find the location, that means we need to find the position, right? So in other words, we need r of 2, right? Because we want to find the position at t equals 2 seconds. And r is what we use as our position vector. So we're given acceleration. We need to get to position. So what we're going to do here is we're going to take the antiderivative twice of the acceleration, because take the antiderivative twice would give us our position. And then how do we know those constants? Like when we take the antiderivative, we get a constant. Well, we get that from the information in the problem, right? So from the description of the problem, we get 2 initial conditions. The first one is that it says an object starts from rest. So what does that mean? That means the velocity at time equals to 0 is equal to the 0 vector, right? In other words, 0i plus 0j plus 0k, because it starts from rest, so it's not moving at all. The other one is that it starts from rest at the point 1, 2, 0. So what does that mean? That means that the position vector at r equals to 0 is going to be equal to 1i, or just I, plus 2j plus 0k, right? So that's what we have there. So those are going to be initial conditions that will allow us to, once we take the antiderivative, solve for the constants of integration, right? So first, we want to find v of t, right? Because we've got to find the velocity in order to find the position. So v of t, how are we going to get that? We're going to get that by integrating a of t, which is given by the problem, right? So what is a of t? A of t is just j plus 2k. I'm going to go ahead and write 0i in here so I don't forget to integrate that. So 0i plus j plus 2k dt. And just because I like to, I want to remember that if I integrated each one of these pieces individually and put a plus c on at the end, remember that plus c is a plus c vector. So it has like a c1i plus c2j plus c3k, right? That's equal to the vector c. But because I don't want to have to remember that, I'm just going to do that thing where I distribute the integral sign to each piece. So this one looks like the integral of 0 dt times I plus the integral of 1 dt times j plus the integral of 2 dt times k. And again, the reason why I like to do that is because now I'm doing each one of these integrals separately, so I remember that each one will have its own constant. Right, so the antiderivative of 0 is just some constant, so I'll just call it c1i. Plus, now I integrate 1, well that gives me t, plus another constant, we'll call it c2 in the j component. Plus, I get 2t plus a third constant c3 in the k component. right? So that is my velocity, but again, I have constants in there, so I use my initial condition 1 in order to find those constants. So using the initial condition, v of 0 equals to 0i plus 0j plus 0k, what do we get? Well, we get that v of 0, when I plug in 0 to our guy here, when I plug in 0 into that, I get C1i plus C2j plus C3k, and I know that that should be equal to 0i plus 0j plus 0k. So what does that mean about my constants? That means that C1, C2, and C3 are all equal to 0. Therefore, my velocity function is just equal to C1 is 0, so 0i, and then tj plus 2tk. So that is my velocity function. So now we need to find our our position, right? Because we're going all the way up position. We want to find r of 2. Okay, so now find r of t, right? And again, how do I find r of t? Well, I find r of t by integrating v of t. Well, what is v of t? That's what we just found. Again, I'm going to plug in a 0 for the I, so 0i plus tj plus 2tk dt. And then once again, I'm going to separate this out. So I get the integral of 0 dti plus the integral of t dtj plus the integral of 2t dt k. And now I integrate each piece. So here I get c1i plus 1/2 t squared c2 plus c2j plus just t squared plus c3k. Right? And now I use my second initial condition. Right? So using the second initial condition, and remember this one was that, I'll just copy and paste it here. Oops. What do I get? Well, r of 0 means go to our function, plug in 0, so that gives me c1i plus c2j plus c3k when I plug t equals to 0, and that has to be equal to I plus 2j plus 0k. So in other words, what we find out, we figured out that c1 has to be equal to 1, c2 has to be equal to 2, and c3 has to be equal to 0. Therefore, what we just find out, that r of t is going to be equal to c1, which is 1, so I plus 1/2 t squared plus c2, which is 2j, plus t squared, and then c3 is 0, so just t squared k. Now, is that my final answer? No, right? The question asked way back when, it said find the location of the object after t equals 2 seconds. So the location of the object after t equals 2 seconds is, we just plug in 2 into this position vector value function that we found. So I get I plus 1/2, well, let's do 2 squared is 4 times 1/2 is 2 plus 2 is 4, so this is 4j plus 2 squared is 4, so 4k. So that is my final answer. That is the position after t equals 2 seconds. Alrighty, that's all I have for this video.